whoever's kid's in the lane timing them.
Right.
I would hope. I would hope they'd pick some random parents and mix it up a little bit. I would hope. So the reason I had you do it 5 times each was because I wanted you to have enough data points to find a median of. So right now, look at your data points. Look at your data points. And find the median of both sets. So you'll have 1 thumb time and 1 finger time. This way we'll deal with any outlier, goofy false starts, or goofy started too early, started too late, whatever. And just circle the median of each of them. Median of each of them. So what we're going to do is, this is still going to be a t-test. So if you're looking at the grand scheme of hypothesis tests, this is just like the one we just did. Except the data is going to have to be processed in a different way. And here's why. We're going to have 2 lists of data, in L1 and in L2. L1 is going to be your thumb times, and L2 is going to be your finger times. L1 is going to be your thumb, and L2 is going to be your finger times. So we're going to start by collecting the data that way. All right, so let's fire up our TI, and all we're going to do, let's take our time and collect this data. And again, it's all about data collection, and it is a bit time consuming. But let's make sure we all get this data in our TIs at the same time. So we're going to wander around and stop to everybody that got times. So Karen, you were running times?
Yep.
Give me your median thumb time.
21.88.
21.88. Your median finger time.
21.82.
There we go. All right. So that's what we're going to do. We're going to wander around to everybody who measured times. Put thumbs. Well, thumbs would be good if I could find a good app. And I haven't found a good app yet, unfortunately. So 21.88, 21.82. Beautiful, beautiful. Jamie, you did not run it. Kat, you did. Thumb time?
2209.
2209. Finger time?
2191.
2191. So we're getting seconds and hundreds of seconds. Seconds and hundreds of seconds. All right. Kill the lights. This is a little more obvious right down here. There we go. All right. Who else? Rich, you were running times. Thumb first.
21.58.
21.58.
21.68.
21.68. There we go. There we go. Beautiful. Beautiful, beautiful, beautiful. Next up, see, spend Ash. Jamie, you were on it. Thumb time?
21.69.
69. And finger?
21.5.
21.5. One thing I wish I had, and I don't, is the actual computer register of the time that they said the guy had.
Yeah.
Because we can form a confidence interval around it and see if we tracked it on average. But I can't find this clip anymore. I Googled it on YouTube, and I can't find this race anymore, so I don't have the actual number on the... It's a trimmed down video. This video was like 10 minutes long, with, as you can see, about 22 seconds of swimming. Because it's all them standing up on the things, like shaking their lats and slapping their butts and getting ready to swim, and then they swim. And then it shows them in the pool, like, breathing, like, because they just swam like every engine. So I cut off the time, and I can't find the race anymore because I cut off the description of the race, too. So, apologies for that. I know, sorry. Who else had times? Times. We got, Darla, go ahead, thumb.
21.71.
21.71, and finger.
21.65.
21.65, excellent. Other times? Mary, go ahead, thumb. 97, and finger?
21.86.
0.86, thank you. You guys are getting pretty consistent, which is making me happy, because it means that we're all pretty much watching the same thing, and the trick is, are we staying consistent with ourselves? Not necessarily each other, with ourselves. We'll find that out soon enough. Who else do we have times for? Go ahead. Nat, thumb?
Thumb 22.13.
22.13, and finger?
21.7.
0.7?
4.
4, all right. And there is variability, of course, in the data. It's just that it's so small that a standard error is going to be very, very teeny, which means a tenth of a second might be significant now. Depends. And a tenth of a second in a race like that is extraordinarily significant. That's the difference between first and last place. Who else we have times from? Times. Jessica, go ahead. Thumb.
21.65.
6.5. And finger.
21.62.
6.2. Very close, very close. Go ahead, Caitlin.
21.56.
21.56 and 5.7. Check that out. Just a second off. Who else we got times for? Ken?
21.72 and 21.81.
All right, fantastic. And we got, go ahead, Zoe.
21.83.
Okay.
And 21.95.
Excellent. 21.83, 21.94, about a tenth off there. Dustin, what do you got?
21.88, 20.7.
20.78. All right, there we go. There we go. Go ahead, Rochelle.
21.41,
4-1.
and then 21.36.
3-6. Awesome. Michael, what do you got over there?
21.795 and 21.78.
21.78. That's cool. How'd you get 3 decimals? Divide.
Okay.
Oh,
He
a
actually
meeting of even numbers.
calculated
Very nice, my friend. Excellent, excellent. Very cool, very cool. I think I saw one more hand. Go ahead, Ashley.
21.58,
5.8 and
21.57.
21.57. Beautiful, beautiful. Is that everybody? Okay. So there's our data. We got our thumb data in L1, and we have our finger data in L2. So let me ask a question. How are we going to test this to see if there's a difference in our fingers and our thumbs? What do you think? Give me some ideas. You test them individually. We can test them individually. So we can run the test on L1 and run a different test on L2. Give me one reason why we might want to rethink doing that. Give me just one reason. That's not a bad idea, Michael. But there are a couple statistical reasons why we might not want to do that. Go ahead.
Each one of these numbers is related to the other.
There's a relationship between your Swedish chef on you. There's a thumb-finger relationship where if you strike the averages individually, you're going to lose that relationship. Exactly. We don't want to test the average thumb time versus the average finger time. We want to test to see if there's a difference in the times between, on average, the thumb and the finger. That's one great reason. That's the best reason. The other reason I was thinking was we're going to lose confidence if we do it that way, aren't we? 95%, 95%, we're down to 90% now. That's the statistical reason, but Michael's got the thematical reason is we're going to lose confidence if we do this way. That's the problem. So we want to test to see if there's a difference between thumb and finger times. So what do you think we should do? Oh, on what, Dustin? I love that. Box plot on. That's a fantastic, Dustin has a fantastic idea to make a box plot or a histogram of L1 and L2 and see if there's differences. I don't want to do it right now. I do want to do it, but I don't want to do it right now. Why? If I run the two box plots, right? Actually, you know what? What the hell? I'll do it. You don't do it in yours. I'll do it in mine, just to show you why I don't want to do it overall. So take this one and modify it here. L1 frequency of 1, and here's L2 with a frequency of 1 modified box plot. Okay, zoom 9. There they are. Okay. Why does this not tell me what I'm interested in? Michael?
Because the numbers aren't relative to one another.
Yes, this low point here might not be equivalent to this low point here. There's an association between every point of the 20 up here and every point of the 20 down here, and I want to compare them to each other. This doesn't allow us to do this. It allows us to look at one in totality and the other in totality. Does that make sense, Dustin? You see what I'm getting at there? So what I want to do here is I want to have something called a matched pair test. I call it a matched pair. I'm not exactly sure if this is a truly common phrase. It's still a t-test. It's still a t-test, but I want a test that will allow me to link up those two data sets. So these two beautiful data sets that we see right here in my stat editor, I want to be able to link them together. So I'm going to ask you a question again. Is there a difference between thumb and finger times? Question mark. Can we set up a difference? Can we see if there's a difference between them? Assuming there's not. Let's assume, hypothetically, there's absolutely no difference between our thumb times and our finger times. So what should this and this look like? They should be the same. What should this and this look like? They should be the same. This is also important because remember how I told you it doesn't matter what swimmer you're looking at as long as you're looking at the same one each time?
Yep.
If you guys were looking at two different swimmers, this one and this one might be close to the same, but these two might be maybe a half second different. But as long as they're looking at the same swimmer, the difference between them should be the same as the difference between them. It doesn't matter if you look at different swimmers as long as you're consistently measuring your thumb and your finger. So what do you think I should be looking at between these two numbers? The difference of them.
The
I want the average difference. I want to do the difference first and then the averages, which is different than doing the averages and then the difference and the averages. It's a fine mathematical statement. I want to do the average differences, not the different averages. Different averages would mean average this, see if there's a difference. I don't want to do that. That loses my association. I want to do the differences and then look at the average of those differences. So here's how we're going to do that because I'm slick. Although I just erased the whiteboard with my hand, so I don't know how slick I am. We are going to place the differences in L3. So watch this. Put your blinker up on top of L3. Put your blinker, we're going to use this, they're going to use the TI like a spreadsheet. And here's what I want you to type into L3. L1 minus, I put plus, L2. And when you press enter,
Boom.
those are your differences. Those are your differences. So what this tells us is, I got a 0.06. That means my thumb in this pair took 6/100ths of a second longer than my finger did. And you can tell that by looking at it, can't you? This is 6/100ths bigger than that. My thumb is 18/100ths slower, if you will, seconds slower than my finger in this one. Negative 0.1, that means the thumb was faster than the finger. So any negatives you see, your thumb was faster. Almost 0.4 seconds slower. Almost 0.4 seconds slower, you're seeing that right there. And you can scroll down and see all the differences. There, you got some negatives down there. Bunch of positives, bunch of negatives. Some very close to zero. So the question I have is, I don't know. I don't know by looking at that what's going on. Hey, you know what, Dustin? May I make a box plot now on just this data? Because now I've got one data set, don't I? I've got all the differences between my thumb. Let's make the box plot on just L3, friends. So I'm going to go back, turn plot 2 off, and just plot 1, but make sure it's looking at L3 with a frequency of 1. I had that set up wrong last time. I had it set to L1, L2. That's okay.
How do we get to that page?
Second Y.
Second Y equals.
Oh, okay.
And then zoom 9. Zoom 9. Okay. Check it out. Got a lot of data here. Ooh. I think that was the 0.39. I think. Let's trace to see. There's a 1.1 difference in there somewhere? Wow, I didn't catch that
there
one.
is.
The 1.1 second difference. That's impressive. So there's the 0.39. The 0.39 is actually within the realm. There's a 1.1 out there that's actually a very exaggerated outlier of a difference. We might want to consider bopping that one out of the data set, because this might pull the average very high. We might also want to consider running it 2 different ways, running it with and without, and seeing if it makes a difference with that one. 1.1 second difference is an eternity in a race like that. That's 5% of the race, right? That's 5% of the race.
That's the normal guy.
Say that again?
That's the normal guy.
That's the normal guy. Maybe like 1 minute behind. No?
Yeah.
I want to look at one more thing, friends, real quick. I'm going to add a second plot onto this histogram. So I'm going to turn plot 2 on as a histogram. L3, same frequency of 1. Same frequency of 1, because I still want to use each of the data points one time. Okay, zoom 9, here she is. There's my histogram. I'm going to do some finagling because I don't like this. Let's see, x-min, let's make it nice pseudo-decimally integral values. X-max of 1.3 and an x-scale of 0.1. Let's see if that window set up right there gives us something interesting to look at. So I made my x-min negative 0.2, which is a little bit below positive 1.3 on the x-max and a scale of 0.1. Let's see if this shows us something interesting, a little more refined than its window it gave us. Not bad! Not bad at all, friends. Not bad at all. I like that an awful lot. I like that an awful lot. So what you're seeing is almost perfectly bell-shaped data. Almost perfectly bell-shaped data with a really interesting outlier. This is fantastic, actually. It'd be great. We'll play this data on Tuesday. What do you think? Are we over or underestimating with the thumb? Is either the thumb or the finger, in your opinion, operating differently than the other? What do you think? Make a call, make a call. Susie, go ahead.
I
Change
would
one
say the
thing,
thumb
too.
is faster because the median is on the plus side.
Okay, so since you have the curve, the plus side of the axis altogether, so Susie's noticing this right here is 0. 0 would imply what? If the curve were centered on 0, what would that imply? That there's no difference. Let's just write one thing down and take this with us till Tuesday. Your H naught is going to be mu equals 0. And if you want to have a unit on that, it would be seconds. So in other words, assuming that the thumb and the forefinger the thumb and your index finger are not different, there shouldn't be any difference in the times. Does that make sense?
Yep.
We're going to test that by mu is either, and I haven't asked you guys for this yet because I'm not sure what we should test, and I don't want to do it in 3 minutes. We'll pick. Should we test that they're not equal? Should we test that it's less? Should we test that it's greater than 0? I don't know. Let's figure that out on Tuesday. We have a little more time to kind of play with it.
Does the difference mean the equal?
It is, and that's what I said here was, is there a difference? That would be not equals. But after hearing what Susie said, she said, since it's leaning to the right, maybe we test greater than. I'm gonna leave it up to you guys on Tuesday. We'll see. We can test all of it if you want to, for that matter. We'll also decide about this outlier out here. Leave the data in your TIs. Leave your data in your TIs, okay? You won't need your lists for Tuesday. You're doing the take-home for Tuesday, right?
Yeah.
You won't need your lists for that. That's just a proportion test. Okay, doke? I'll try to get progress reports out this week. I'm going to do my damnedest. I'm sorry if I don't. I'm going to do my damnedest to do it, though. I'm going to get these things graded and back to you guys. What's up, Al? Oh, look at you. What's number 3? Let's go look. Well, we can pull it up on the line here. Let's just take a look. Let's take a look. Good for you. Oh, good for you.
Yeah.
So you ended up down here. And that was the 2. Right, that was the 2.
I like
Okay, so what's your estimate? Right there. Okay. Question is, in order for us to
What is it? If you film this one easy, that one is easy too.
Yeah, that seems to be the one time that we always insistently can do that. Like 5 o'clock Saturday. But since we have the print screen, I'm going to go. Because we have my house.
That should be.
I can hear the restroom. I'll be right back.
I was actually looking at work. You got a milkshake, didn't you? Usually it works better when you got the best part.
Wherever you say.
Oh, interesting. Just do 9 when it's down, my friend. Do 9 when it's down. See it, my friend? Okay, so no. Back. We're going to shape your right. Oh, well, you could if you put 0.95. Right, it's like our time left. Here comes, here comes. It's not longer. There you go, you got it now, you guys.
And it's simple stuff.
I know.
But not really.
I know, right? I overthink it every time. I'm staring at that problem like, what do I do?
I know. It's anxiety.
All good? You're overthinking it. You're thinking too hard. Don't worry, you get back on Tuesday with this. Cool? There, get that next file. That's my file. Okay.
We're sitting here studying and what's the name?
All right. Let me shoot my notes. You should be. And and part of my problem is I should have seen that happening, but I didn't notice it happening.
See ya.
I got you. Okay. Let me look at this and also contact him and find out. That's crap. I apologize. I think I'm telling you. I'll chop that. Chance.